introduction. Okay, so generally, what's the elements in statistics and what kind of terms, what kind of data we're gonna use, it will be discussed here. Okay, so the first chapter, introduction. So first thing, statistics can be divided into two parts. Okay, so sometimes we say categorized, sometimes we say divided. And the two parts is the first one, descriptive statistics. Okay, descriptive statistics. The second part, inferential statistics. Descriptive means description. Okay, so we have a whole bunch of data and we want to know, okay, what those data mean to us. So somehow we need to organize them. Okay, we need to organize in certain way to make the data informative to us. So for example, stock price. Okay, so there are so many stock companies. How can you get the idea right away? So what's going on in terms of the trend of the price? Of course, you need to organize it. And one way to organize it is according to industry. So in Taiwan, the most popular one is electronic industry. And sometimes, you know, at this point, traditional industry like steel company, okay, steel, and some other kind of companies like shipping, okay, airline, all these kinds. So you have to have a certain way to organize it. So if you just tell us the stock price index, so today the stock price index going down, I think it is like 42 points. Okay, but it is for the stock index is composed of all the companies. So the stock index is going down, right? Does that mean your company or the company you invest is going up or down? You know, it is an average. So you have to know the stock index is a general trend. It doesn't tell you specific which company is going up or which company is going down. So because of that, you need to certain way to organize it. Okay, so you just tell us, you know, and stock analysts just tell us, you know, the price is going to go up or down. It doesn't make sense. It has to tell us which company and what's the trend. Okay, and of course, after you get all these data, you want to know, okay, what's going on in terms the future, right? The price you get right now is what's going on in the past, okay? In the past, the price goes up. Does that mean in the future the price going to go up too? No, it's not necessarily the case. So you have to get the information in the past and try to infer from those information to what's going on in the future. So these are the very important part here. Okay, and what are the ways to organize data? Generally, we use charts or table, okay? And because now computer is so popular, okay, and also Excel program, I think everyone is familiar with that. So in this class, we won't spend too much time on those topics. But you know, generally, in terms of the charts, there's line chart, bar chart, and pie chart, and histogram. Probably histogram is the new thing to you. Okay, how many of you have heard of histogram before? If you have heard of this before, please raise your hand. So histogram is kind of special because there is a certain way to organize, okay, to draw this kind of chart. It has to be based on probability. Okay, so later on we're going to introduce this a little bit. Okay, so let us continue. Okay, so you know, basically statistics is a class teaching you to deal with data. Okay, so how to deal with data. So the first thing, okay, if you want to study anything, stock price, okay, the height or the score of the class, okay, you need to know where to get these data. Okay, so the first thing is to collect data. And for the data you're going to collect, there are two different ways. The first way is first hand, okay, and the second way is second hand, okay. What means first hand? So for example, for most of us, okay, when we want to study stock market, where are we going to get data? We don't collect the data ourselves. Oftentimes you pay. There's a company, I think it is called Taiwan Economic Journal, okay, Taiwan Economic Journal. This company, they collect all the data and then they sell the data, okay, in CD-ROM. So generally, sometimes, okay, of course, if you have time, you can collect these data yourselves. But generally, at this point, there are some companies specializing in providing data. So oftentimes, in this case, generally when we start the stock market, we just pay and to get the data from a company. Okay? And there is, of course, there are a different way. So for example, if you are interested in the risk preference of your class, okay, if you are interested in the risk preference of the students of NKFUST, suppose that is the case, then how are you going to deal with this? Then you can get a survey, okay, you get a questionnaire, okay, questionnaire, this whole bunch of questions, and ask people what's your preference, which kind of company you're going to invest. This is one way. You hand in questionnaire, ask people questions, or you telephone, okay, you call people, okay, and you ask a list of questions. And then that would be the first-hand data, okay, the first-hand data. But generally, you don't have to do that. Because at this point, a lot of companies, they provide data for you. And they are sometimes second-hand, okay? So for example, you get data from Taiwan Economic Journal. This company, they provide data, right? But somehow it is raw data, okay? Raw data means it is just numbers, nothing there, okay? But of course, when you get these raw data, what you're going to do? You're going to analyze it, okay? You're going to organize it, and you want to see what's the trend. So after a trend, you say, okay, because the oil price is just too high now, okay? So today, I think it is yesterday, it increased to $48 one barrel. But if you remember 2 weeks ago, how much is one barrel of oil? It is about $42. So now it increased more than 15%. And so, okay, from all these trends, you collect all the data, and you want to see what's going on there, right? So sometimes, okay, second-hand data, sometimes you're going to use this, okay? And then, so basically I just mentioned something about the second part. You have to classify it and present the data, okay? So let us say you know the information about oil prices, okay? When you get these information about oil prices, and now you want to analyze stock. So let me ask you, what about airlines? So now you know the oil price is going up. What will happen to the stock price of airline companies? Oil price is going up, and airline companies use a lot of fuel, right? Use a lot of oil. So the oil price is going up. What would you expect in terms of the performance of airline companies? It is going to go down, right? So if you pay attention to some of the international business news, you know that United Airlines is under bankruptcy protection, and another company is U.S. Airways. It is the second time U.S. Airways under filed Chapter 11 and under the protection of bankruptcy law. So you can see, this is the second-hand information. From there, you can analyze what's going on in terms of the airline company. So let me ask you this question. If you have money, do you want to put your money into Evergreen Airline, EVA? No, right? Because now the oil price is continue to go up. And the trend, I think, when winter comes, okay, when winter comes, what is going to happen to the demand for oil? Because a lot of countries, they live in high altitude, right? When it gets very cold, it snows. What would you need? You need to get warm, right? What would you need? You need oil, you need gas, right? So the price is going to go up further, right? So this is not a good time to put your money into shipping company or airline companies. Okay. Of course, the third part, analyze and interpret data. Okay, so this is what I've just done before, right? Just a few minutes ago, we say oil price, okay, stock price, and then we sort of connect these two things together, right? So because airline companies, shipping companies, they use a lot of fuel, right? So the costs go up. What happened to the profit? The profit go down, okay? And then inference, right? Inference, of course, suppose you are in the energy industry, okay, or you are the analysts for the energy companies, then probably you're going to see, okay, if the airline companies is going down, what happened to the oil company? It is going to go up, right? So there is no such an evil wind that blows no one good. So of course oil price go up is bad for the airline company, but they are good for the energy company. So ExxonMobil, Shell, right? And some of the oil companies in Taiwan, or they produce plastics, what happened to their stock price? Going up, right? So from all these kind of information, and then from all these inference, okay, what would you see? You find out your investment strategy. Okay, so this is the most important thing you're going to learn in this class. Okay, let's turn down further. So now we get to the, the objects we are going to study. So for the objects we are going to study, there are two kinds. The first kind is called population, okay? And the second one is called sample. And what is population? Population means every object you are interested in your study. That is what we call population. So everything in your interest, and you want to study them. So for example, if you are interested in the general performance of the stock price, then you are research the whole market. But suppose you are only interested in the electronic industry, then what happened? That is part of the population, and that is called sample. So here the example I have is about students. So for example, you are interested in the statistics, okay? So many people study statistics, and you want to know which group is more efficient in learning statistics, or which teacher is more efficient in terms of teaching. And so you are interested in the whole population, that is the whole students. But sometimes you can see a difference, say female and male, right? As you can see, sometimes female concentrate more than male. And so here, if you want to study male or female, and that is part of the population, what's that called? That is called sample. Okay? Any question? Did I go too fast? So far, so good? Okay, let's move on. Okay, so the major characteristics of data. So when you get a whole bunch of information, what would you want to know? You want to know two things. The first one is central tendency. Okay, central tendency means mean. And what does mean? It is average. So oftentimes we say on average the stock performance is good or bad, okay, of the electronic industry, airline industry. Generally, we want to know what's going on there. Okay. The second one is called dispersion. Dispersion is how far the data spread. Okay, how far the data spread. Let me give you one example here. So for example, this class, we are interested in the height. Okay, how tall you are. We are interested in the height. So let us say the average for this class is 165 cm. And another class, it is the same thing. The average is 165 cm. But does that mean, okay, does that mean these two data are the same? Not necessarily. So for example, let us say, in the first class, the height, okay, the distribution is much more even. So let us say, to put it more extreme, say everyone is 165, okay? But then for the other class, even though the average is also 165, let us say there may be someone 190, 180, and there are some people 150, 140, right? So even though the average is 165, does that mean, okay, the two classes is the same? No, it is not. So for example, the same thing. Later on, after you become a stock analyst and you tell people, say, for this group, electronic industry, the rate of return is 5%, okay, and the traditional industry, it is also 5%. And then, in this case, in which company you're going to advise people to put their money in? But in terms of electronic company, okay, the companies in the electronic industry, generally the rate of return vary and vary greatly. Okay? So some of the companies, they have very high returns. Some of the companies have low return. Okay? So let us say IBM or HP. Okay? IBM, HP, and there are some other companies. Let me see. Oh, Apple, right? Apple. All these companies. Okay? So on average, even though the rate of return is the same as the car company, GM, Ford, Chrysler, okay? But as you can tell, HP, okay, the performance is not good. Or after they have merged with the Compaq, generally the performance is continue to go down, okay? But what about IBM? IBM has strong performance, okay? So in this case, okay, you can see the same kind of industry, even though the rate of return, the average rate of return is the same. But, you know, if you want to put your money in, probably traditional industry like car company may be better bet. Because somehow, if you put all your money into the electronic industry, you may, of course, have some money into IBM, but you may have some money into HP. Some of good, some of them bad, okay? So these are some of the details you need to know very clearly. Even though the average is the same, what about the dispersion? Okay, you have to be very careful about that. And in terms of the dispersion, there are two ways to measure them. The first one is variance. Okay, variance, and the second one is called standard deviation. Actually, these two are the same thing. How to get standard deviation? You take square root of variance. Okay, if you take square root of variance, then you get standard deviation. So basically, these two are the same thing. Let me mention a little bit here. Mean means average, right? But we have two kinds of average. One is what we call arithmetic average, and the other is geometric average. Okay, later on we're going to talk about it. Okay, and here there are some special terms when we refer to the numbers we are using. Okay, so here, the statistics for population are called population parameters. Okay, here statistics is no longer about a class. It is a number. Okay, it is a number. So when you use the number to refer to population, what are those numbers called? They are called population parameters. Okay, and when you use a different kind of numbers to use for samples, what's that called? It's called sample statistics. Okay, so for population we call population parameters. Okay, the number. So we have population mean, population standard deviation, and population variance, right? For those numbers we call population parameters. And there are some numbers, okay, average for sample, variance for sample, and standard deviation for sample. What's that called? It is called sample statistics. Okay, that's just basically the same number, but when you refer to population, it is called parameter. When it is referred to sample, it is called statistics. Okay? Okay, so there are several kinds of data we are dealing with. Okay, the first one is we call qualitative. Okay, qualitative means it is about certain kind of property. Okay, so here you have education, sex, and occupation. So education, you have elementary school, middle high school, that is junior high school, and senior high school, and of course university, and then postgraduate school. Postgraduate school, it is the master program or the PhD program. So for these kind of data, okay, basically you say, 1 stands for elementary school, 2 stands for junior high, 3 stands for senior high, even though, okay, it is numbers, but does it really talk about number? Can you calculate a number? No, okay? So here it is a qualitative, okay, talking about the property. So here another example, sex. Generally 1 would be for male, right? 0 would be for female. Can you calculate this number? 0 plus 1, 1 plus 1, does it make sense? No, it doesn't make sense because 1 just means male, right? And 0 means female. If you have 0 plus 1, what do you get? You get 1. But does that mean if you have 1 male and 1 female, then you get 1 male? It doesn't make sense that way, right? So there are some data that you can calculate, but there are some other kinds of data you cannot calculate, okay? The same thing for occupation. So I'm in the education industry. Later on, you may be in the financial industry. Some people may be in the construction industry. Okay, so this is occupation. Also, we talk about numbers, okay, but it doesn't make sense to calculate those numbers. But for the other kind, it's different. So let us talk about quantitative. Quantitative is about quantity, right? Quantity usually can be calculated. So like height, like weight, okay, like your income, right? Okay. And here there are something that more specific. Probably later on when you get to some research methodology, you will talk about this. It's about cross-section, okay? Cross-section means it happens at the same time, okay? So at this point, we are interested in the performance of this economy, okay? So this is 2004, okay? We are interested in the unemployment rate, okay, inflation rate, okay, and the GDP growth rate, all these kind of rate. We are talking about at a certain point what happened, and this is cross-section. And later on, okay, the next one is time series. Okay, time series is what we talk about quite often. So for example, the performance of stocks in January, okay, February, March, etc. Okay, from the beginning of the year to the end of the year. Okay, so this is a time series. GDP, okay, GMP, all this kind of stuff like trade deficit, trade surplus, okay, foreign exchange, all this kind of stuff. We have a lot of things about time series. And the second one, the next one, discrete. We talk about it, right? Discrete type of data, it is about integer, okay, integer. We talk about in the whole number. So like one car, okay, two cars, three cars, or one person, two persons, three persons. Cars and persons, it is in terms of the way we talk about it, it is discrete. And what about the other things? It is called continuous. Okay, continuous. Generally, it is real number. It has decimal points. Okay, it has decimal points. So like fraction. Okay, such as height, weight. Okay, all these things. Any questions? Let us move on further. It will be the next chapter. Shall we take a break here? Okay, so let's take a break here. Going to discuss descriptive statistics. So what's generally about it? We have central tendency, right? We have dispersion. So what are the measurements for this? And also what kind of data we are dealing with? So we just mentioned there are some qualitative data, there are some quantitative data. So depending on which kind of data you are referring to, sometimes it can be calculated, sometimes it cannot. And so how are we going to deal with it? So here is generally the discussion about all these. And also how to organize data, okay? And how to calculate mean, how to calculate variance. What about sample? What about population? Okay, so these are the things we're going to discuss in Chapter 2, descriptive statistics. So if we are dealing with the whole population, that kind of research method is called census. So if you are going to deal with everything in the population, it is a census. And if you are just going to deal with part of the population, what is that? It is called sampling, okay? Because sample is part of population, right? And if you are dealing with a sample, it is called sampling. Okay. So census survey every object of the population. And what about sampling? We're going to take part of the population to study. Okay. So basically that's the two differences there. And of course you want to know why. Sometimes we just use sample and we don't want to study the population. Because of course it seems to be more accurate, okay, more precise if you can take every object in a population and study that, right? But there are a lot of things that you need to be very careful about. Why we don't do that? The first thing, because of the cost, right? If you're going to deal with every object in the population, it must be very expensive. So for example, we are interested in the learning curve, okay, the learning efficiency of the students of this school. How many people do we have? We have more than 5,000 students in this school, right? And if you are dealing with 5,000 people, how much it's going to cost? And how much time it's going to take, right? So too much time and too much money. So because of this, sometimes we just use sample, okay? But here, if you use part of the population, and that is sample, right? If you are dealing with sample, you have to be very careful. Why? It has to be that the sample reflects what's going on in terms of the population. So let me give you this example. In 1960s, okay? In 1960, of course, that's a long time ago, okay? At that time, telephone was getting more and more popular, okay? But as you can see, at that point, telephone is very expensive to have. So what would you imagine? Who is going to have telephone? Who is going to have telephone numbers? It is those rich people, right? Okay? So at that time, there is a polling company, okay? Polling company, that means they're doing survey for people and trying to get to the opinions of the people, see what they think about in terms of presidential candidate, okay, or whatever kind of policy issues. And at that time, they are dealing with presidential election. And so they know that telephone is quite convenient, right? So they use telephone as their tool and to get a telephone survey. And according to that telephone survey, what happened? The result shows that Republican presidential candidate gonna be elected. Okay? What happened? The result is that Democratic presidential candidate got elected. Okay? So it is not the Republican, it is the Democratic. So here, what's going on? Is there anything wrong? Is there anything wrong about this polling method? Because in this case, the sample does not reflect what's going on in terms of the population, right? So if you want to survey, okay, if you want to know what's going on in terms of the election result, you have to ask the sample, okay, when you take the sample, it has to reflect what's going on in terms of the population. But what happened? You are using telephone to get a survey, right? Okay, and this kind of sampling is biased, okay? Bias means it is wrong, okay? Bias basically means there is something wrong here. Bias. In the whole society, there are rich people, there are poor people, right? But what about if you use telephone? You only survey rich people. And rich people favors Republicans. Okay? So what happened? It is a sampling bias. Okay? It is a sampling bias. So when you are dealing with a sample, you have to make sure that the sample reflects what's going on in the population. In the population, there are rich people, there are poor people. But in this case, what happened? They only survey, they only call rich people, right? Only rich people have telephones. So this is wrong here. Okay? So first, if you want to deal with sample, that's fine. Okay? Because a lot of time we just do that. Okay? We use sample to study it. But you want to be very careful here. So for example, if right now you want to use telephone as a tool to ask about people's opinion for the year-end election in Taiwan, what is going to happen? A lot of people don't have fixed line telephone, but you have cellular phone, right? A lot of people have cellular phone, but they don't have fixed line telephone. So the same thing here. If you want to use telephone, cellular phone as a polling tool, there is going to be something wrong here. Okay, so the reason we use sampling has a second reason. The second reason is destructive tests. Okay, what means destructive test? So let us say you want to know how long, okay, the light bulb can last. Okay, if you want to know how long the light bulb can last, of course you have to turn it on, right? And when you record it, how long, okay, it takes for this light bulb to go off. Okay? But then, what happened? If you are a company producing light bulbs, you want to sell light bulbs, right? But if you have every light bulb to have this kind of test, what happened? You don't have anything to sell. Another example is car, okay? So in the United States, there is a Highway Safety Administration, okay? This Highway Safety Administration, of course, they want to evaluate, okay? They want to evaluate, see which car is stronger, okay? And which car is more safe, okay? Is safer to drive. Of course, if you want to know that, what you're going to do? You have to do a crash test. What means crash? What means crash test? So if you want to know how safe, okay, what's the safety features in this car and how and what kind of impact can it survive, you have to have this car to hit a wall, right? And driving, let us say, at 50 miles per hour, and then you hit it. Of course, the result can show, okay, this is a good car because it is safe, okay, and some other cars is bad. But can you do this for every car? No, right? Because if you do that for every car, what can you sell people? Nothing, right? So this kind of test is destructive. It can destroy the product. And for the company, they want to sell the product, right? How can you do that? So because sometimes, okay, because the production is according to some kind of scientific method, okay, a very uniform method, and so you just have to get some of the cars and do the test, and that is quite enough. Okay, so because sometimes the test can destroy the product, so oftentimes we use sample, we don't use population. And the third point, it is difficulty in gathering population. For example, and now, okay, because of the development in terms of biotechnology, bio means biology, okay, B-I-O means biology. Biotechnology, it is about medicine, okay? So of course you want to know whether this medicine is effective or not. So of course you have to have two groups. One group we call control group, and this group is not given medicine, it's given something else. And the other one is called experiment group. And of course you want to know, okay, the experiment group, we use medicine, okay, the medicine we have, and the other group use something else. It is not a medicine. Of course you want to see what kind of difference there. But as you can tell, generally, two persons, if we don't have any relationship in blood, okay, then, you know, there is just too much differences there, okay, so what you're going to deal with it? The best you can have is to have twins, okay, because twins, they have the same kind of DNA, okay, and so here you can see clearly the difference. But can you do this kind of experiment? Very hard, right? How can you get twins? Okay, there are so many twins and spread around Taiwan, okay, in terms of the world, that's even more widely spread. So in this case, it is very hard to deal with this kind of situation. So what can you do? You can only get some samples, okay? And also, there are some other issues here, okay? There are some other issues here. Even if you get twins, or even if you get twins, it is quite different. It depends on whether it is from the same egg, okay? From the same egg, okay? If it is from different eggs, there is going to be more difference there, okay? So we don't want to get into too much details, but this gives you some information. You know, sometimes it is very difficult to do research, okay? If you want to get all those population together and to deal a sensible, to do a sensible experiment, sometimes it's quite difficult. So you have to be satisfied with what you have. And because too much time, too much money, okay, we have only limited resources. Okay, the fourth one, as a matter of fact, this is the most important reason we have sampling rather than census. Okay, because oftentimes, because we have statistical theories, okay, with statistical theories, we can infer what's going on in the sample to the population. So if you study the sample, that is quite enough, because from the sample you can see what's going on in terms of the population. Of course, in this class, later on we're going to deal with all these. Okay? Questions? Move on. Okay, so here we talk about beware of sampling bias. So I just mentioned, right, telephone polls. Polls means a kind of survey. So in the past, only rich people have telephone. And now, almost everyone has a cellular phone but don't have a fixed line telephone. So if you want to use telephone to do a survey, you got to be very careful. And another one is called email, right? If you're going to use email survey, in terms of the United States, it's not a problem because almost everyone know how to use computer. But what about Taiwan? For example, my parents, and maybe your parents, do they know how to use email? Probably not, right? So, but as you can see, sometimes you get email survey. Some people email you and ask you a whole bunch of questions and want to ask your opinion, right? But is it scientific? No, it's not. It only asks those people know how to use email, okay? So the most important thing is sample must reflect population, okay? So the example I gave you, the presidential campaign, right? You have to ask poor people and rich people because in the whole society there are these two kinds of people. But if you use telephone in the 1960s, you only ask Republicans, okay? Okay, now we are dealing with data, okay? What kind of data do we have? We have 4 kinds of data. So measurements for data. Nominal, the first kind. Ordinal, the second. Interval, the third. And ratio, the fourth one. So nominal, NOM. NOM means name. Okay, NOM means name. So basically that's a qualitative data. So if it is qualitative data, can you calculate it? No, you cannot calculate it, okay? So we're going to deal with it now. Nominal, okay? Nominal basically means category, okay? So the number has no meaning in calculation. So for example, like sex, zip code, right? So the zip code in Kaohsiung is A11 here, right? In Taipei, 110, okay? So 110A11, you add it together and take average of it. Does that mean the location is in Taichung, in the central part of Taiwan? No, not necessarily, okay? So sometimes the number is sensible only in terms of which category, okay? You cannot calculate it, you cannot add it, you cannot multiply it, or even divide it. It doesn't make sense there. Okay, the second one, ordinal. Ordinal means order, O-R-D-E-R. Okay, ordinal basically means order. So order, you basically know that the higher the number, maybe the better, or maybe the worse. Okay, so for example, if people give you a questionnaire to have a survey, right? Generally they say, how much do you agree with this statement? Okay, in terms of scale, 1, 2, 3, 4, 5. The higher the number, the more you agree. Okay, the lower the number, the less you agree. So in this case, the number has some meaning. So the higher the number, the better it is, or the worse it is, depending on the situation. So here, the order, okay, 1, 2, 3, 4, 5, it has some meaning. Okay, the higher the number, the better. But 5 and 4, 4 and 3, the difference is 1, right? But does that mean, you are less satisfied by 20%? Is not necessarily the case, okay? So here, oftentimes we have preference, okay? You use it to measure preference. And the higher the number, the stronger the preference. But the difference is hard to interpret, okay, like satisfaction level. Okay, does that mean you feel 2 times more satisfied? So suppose you choose 5, right? And some people choose 1. Does that mean you are 5 times more satisfied than the other? No, it's not necessarily the case, okay? Okay, then interval. So here, meaningful for in the number and the difference, okay? And what kind of example we have? Temperature, okay, temperature. So say today, I think the temperature may be 30 degrees Celsius, okay? 30 degrees Celsius, and let us say the other day when typhoon came here, right? It is 25 degrees Celsius, okay? You can see the difference. So 25 degrees Celsius, of course, is much cooler than 30 degrees Celsius, right? So here the difference has some meaning there. Okay, the difference has some meaning there. But you cannot add them. Okay, so for example, 100 degrees Celsius is the boiling point, right? Is the boiling point. But does that mean, 50 degrees Celsius, the heatness, okay, the hot you feel, does that mean is twice the difference? Not necessarily the case. Okay. The next one, okay, the last one is ratio. Okay, and this kind of data, it can be calculated, divided, okay, add, minus, okay, and subtracted. Okay, so here you can use all sorts of operation. Okay, you can use all sorts of operation like height, okay, like weight. So for example, if you are 100 cm tall, right, then the other guy is 200 cm tall. He is exactly twice your height, right? So here, so let us say my weight is about 70, right? So let us say someone is 35 kilograms, okay? So his weight is 35 kilograms. Then you know exactly I am twice his weight, okay? So here you have something exactly the case. But for the ratio, for the interval and for the ordinal, that's different, okay? That's different there. Okay, let's move on. Okay, so we are going to talk about an example, how to organize data. So we try to organize some data on the height of a class. So here, there are something we want to be very careful about. So because for the whole class, some people are tall, some people are short, right? So oftentimes you have so many people in one class. How are you going to deal with it? Sometimes you have to categorize it. You have to divide them into several groups. Okay, so for example, you have, for those people in 170 and 175 centimeter as one group. And then the next group is 170 to 165, and then 165 to 160. So you have to divide them into several groups. That is easier to see what's going on there. Okay, so frequency. What means frequency? Frequency means the number of times it happened. So let us say we have 5 people, okay, in the group of 175 and 170 cm. So the frequency is 5, okay? So frequency means the number of times, okay, you show up. And what about relative frequency? Relative frequency is the frequency divided by the whole number. Okay, so let me put it here. So frequency, so let us say in a certain group. So this is the frequency. The example we have is, say you have 5 people within the 175 and 170 cm, this group. So we have 5 people. But let us say the whole class, we have 50 people, right? So what is the relative frequency? Relative frequency is denoted as RFI. I means either group, okay? We don't specify as any group, so it can be any group, okay? RFI is relative frequency. It is equal to frequency divided by the number of the whole class. So let us say we have 50 people in this class, and we have 5 persons in 175 to 170 cm, okay, their height is in this group. Then the relative frequency would be 5 divided by 50. So what is the relative frequency? 0.1. Okay, so basically, frequency is the number of times certain group shows up, and relative frequency is about the ratio. Okay, so it is 10%, okay, or 20%, depending on the case. And generally, we can reflect. As a matter of fact, relative frequency is something similar to probability, right? So let us say we have 5 persons in 175 to 170 cm, and the whole class has 50 people. So what's the chance when you select randomly from this group of people? What's the chance it's going to be 4 into 175 and 170? It is 10%. Okay, so let us move on. Okay, so we have a table here. So we have frequency table and about relative frequency. Okay? So basically we have different groups. The first one is class. So which group is this group? Okay? And then we have a midpoint. Okay? So let us say we have 5 persons within the 170 and 175. Okay? And what's the midpoint? The midpoint is 172.5. And the relative frequency, because I use a different number, okay? Here I use 56. The whole class has 56 people. So 5 divided by 56 is equal to 0.089. Okay, so let us show all of the table here. Sorry. So, okay, here. So in this case, we have several groups. 1, 2, 3, 4, 5, 6. We have 6 groups of people, right? We have 6 groups of people, and the total number is 56. Okay, the total number is 56. And in terms of relative frequency, the total would be 1. Okay, the total would be 1. Is 100%. And so here you can see this is the data, and there's something going on here. Okay, so which group has the highest number? Which group has the highest number? It is this group, right? 155 to 160, right? This group has the highest number. And so then, of course, later on we're going to learn how to calculate mean, okay, the average of this class and how we do that. Okay? So this is one of the examples. You have a group, okay, and you want to organize it, okay, you want to present it, then you have to divide them into several groups. And so in this case, it's much clearer here. Or otherwise, what else can you do? You can list all the people, right? So say number 1, it is 179 cm, and then sort them in a ascending order, okay, and put them in this case. But can you see a trend there? You cannot. Okay, so here that is the better way to organize the data. Okay, so this is a different way, right? Here in the last screen we have a table, right? And here we have a chart. Okay, is a diagram. Okay, this is called a bar chart. Okay, bar chart. And here we want to learn something because very soon we're going to learn all the formula to deal with average, to deal with standard deviation, to deal with variance. So here we need to learn some kind of notation here. This is called summation. Summation means to add them together, okay, to add them together. So if you're going to add things together, there are several ways, okay? And sometimes because the number is just too long, okay, we have a long number there, so sometimes we want to get a shorthand, okay, we want to simplify the way to get it. So here we have, so you see the screen here, right? So we have x1, x2, x3, and etc. to xn, okay? So let us say you want to add them together, x1 plus x2 plus x3 plus xn, okay? So of course you can put all the numbers together, right? That is one way. But it's too long, right? So how to deal with it? We use this notation. It is called summation. Okay, this is called summation. And here you are dealing with x1, x2, x3 to xn, right? So then you have I is equal to 1 to n, okay? And then this is xi. This is a summation notation, okay? So I is equal to 1 to n. So here the first one is x1, the second one x2, the third one x3, etc. Okay. What about the second one? The second one, we have all the odd number item, okay? The odd number 1, 3, 5, 7, 9, 11, 13. This is odd number. And then the third one, it is even number. 2, 4, 6, 8, 10, 12, 14, 16. These are the even number terms. Okay? So how to deal with that? The same thing. x2 plus x4 plus etc. to x to n, right? So how to deal with that? The same thing, summation, okay? So this is the even number term, right? So you have x to I, right? And here you start from I is equal to 1 to n, right? So the same thing here. And here it is odd number, okay? 1, 3, 5, 7, etc. Okay, let us look at another example here. Okay, so basically, you know, the first thing we have, it is from 1 to n, right? So of course I will be equal from 1, I is equal to 1 and then to n, right? What about this example? How many items do we have? 1, 3, 5, 7, 9. How many do we have? We only have 5, right? So here you have summation I is equal to 1, right? And to what? To 5, because you only have 5 items. Okay, you only have 5 items. And of course, the first I is equal to 1, okay? The second I is equal to 2. So if I is equal to 1, 2 times I minus 1 is equal to 1, right? And when I is equal to 2, 2 times 2 is equal to 4, right? 4 minus 1 is equal to 3, right? So basically, you have to learn this kind of notation. Very important here, okay? Okay, let's look at the next one. 2, 4, 6, 8, 10, 12. How many items do we have? We have 6 items, right? So then I is equal to 1 to 6, from 1 to 6, and that is 2i, right? Okay, and here, you've got to be careful a little bit, right? Here you start from 4, 6, 8, 10, 12, 14. So it is the same thing. It is the even number, right? But it starts from 4. Okay, so I should be start from 2. Okay, and from 2, I is equal to 2 to 7, right? Okay, you got to be very careful here. Okay, so here are some of the notation you have to learn. So later on we're going to review a little bit. Okay, so very important. Questions? Okay. So we're going to get to the important thing here, central tendency and dispersion. Okay, central tendency is the mean. Okay, so basically you need to calculate the mean and variance of the data and make sure that you get the formula right. Okay, so there are some formula you need to be very careful about, because in terms of population and sample, we have 2 different formulas. Okay, let me mention this very clearly. For population, of course, the statistics for population, we say they are population parameters. And the statistics for sample, it is called sample statistics. And they have different formulas. Okay? Okay. There are a whole bunch of number of here. Okay, I'm not going to confuse you. Let me put it on the blackboard here so that you can see what's going on. I think, or maybe let us take a break here. Okay, let us take a break here, and then we're going to move on in next hour. Of calculation. So about mean, population mean, okay, sample mean, population variance, and sample variance. So there are 2 kinds of data. One is grouped. If you have group data, then here you have frequency. Okay, Fi is frequency. Okay, and so in this case it is a group data, and we're going to discuss ungrouped data first. Okay, so population mean and sample mean. Population mean, it is denoted as mu. Okay, this is pronounced as mu. Mu x. Mu x is equal to 1 over n summation xi. I is equal to from 1 to n. Okay, so this is population mean. And what about sample mean? Sample mean is denoted as x bar. Okay, sample mean x bar. It is equal to 1 over little n. Okay, to make the difference between population. Okay, to show the difference between population and sample. For population we use big N. For sample we use small n. So summation xi is equal to 1 to n. Okay, so this is population mean. This is sample mean. And now we're going to get to variance. Variance is denoted as sigma x squared. Okay, this is pronounced as sigma. Okay, sigma x squared. It is equal to 1 over n summation xi minus mu x squared. Okay, remember this is ungrouped data. Okay, like the height we talked about for a class, right? They are divided into several groups. Here, there's nothing here. It is ungrouped data. Okay, this is we call ungrouped data. Okay, and what about sample variance? It is x squared. Okay, sx squared, and then it's equal to 1 over n minus 1. Okay, be careful here. 1 over n minus 1. This is for sample variance. And here it is for population variance. Okay? And it is equal to summation xi minus x bar squared. So you can see a difference here. Okay, here I put down I is equal to 1 to n, right? Because it is just too tedious. So oftentimes I will miss all these things. Okay? So generally I'll just say mu x is equal to 1 over n summation xi. And what does this mean? Of course this means from I is equal to 1 from 1 to n. Okay? So later on these two things will be missed here. Okay, will be omitted. Okay. Now the important thing is to simplify this formula. Okay, there's one way to simplify this formula. How to simplify it? Okay, let us try. Here you have 1 over n, and then you have summation xi. Because it is xi minus mu x squared, right? So we square this part. This part will be xi squared minus 2xi mu x, okay, and plus mu x squared. Any questions so far? Because this is a square form, right? We expand it, okay? A minus b squared is equal to a squared minus 2ab plus b squared, right? Okay? Any questions so far? Questions? Okay, let's move on. So here you have 1 over n, and then you have summation xi squared minus summation 2xi mu x plus summation mu x squared. The reason we can do this kind of operation is because this is summation, right? This is summation. So a plus b, okay, is equal to b plus a. You just expand it, okay? You just move. The operation is this simple because it is this one add this one, right? Okay, so which one is added first? It doesn't matter, okay? So here. Okay, and then, you know, there's something we have to deal with, okay? So here it is equal to 1 over n, and here summation xi squared. And so how to deal with this part? Okay, how to deal with this part? So we have x1 plus x2 plus xn is equal to summation xi, right? Okay? Here it is equal to this. And what about here? 2x1 plus 2x2 plus 2xn is equal to summation 2xi, right? Okay, any question here? So you have x1 plus x2 to xn is equal to summation xi, right? And you have 2x1, 2x2, and 2xn, it is equal to summation 2xi, right? And what is this equal to? 2 summation xi, right? Okay. So what happened? So we can move this out. Okay, we can move this out. And here you want to be very careful here. Mu x, okay, mu x, it is a number, right? And it is a constant. Because population mean, if you can calculate it, you know it. Okay, so this is a known number. Okay, this is a known number. So the only thing affected by summation is xi. Okay, so the only thing affected by summation is xi. So we can move 2 out, and also we can move mu x out. Okay, so here you have summation xi squared, it is here, and then minus 2 mu x summation xi plus, okay? So you have summation mu x squared, right? So how many will be here? Because this one is added from 1 to n. So how many times do you add it? You add it n times. So you have n times mu x squared. Any questions so far? Any questions? Okay, let us move on. So then what do you have? 1 over n summation xi minus 2 mu x. What is this? What is this? This is summation xi, right? So when you look at it here, summation xi, okay? So what is summation xi equal to? Summation xi is equal to mu x times n, right? So summation xi is equal to n times mu x. And so what is mu x equal to? Mu x is equal to this one divided by n, okay? So we can put it here, right? So summation xi is equal to n times mu x, okay? So this one is equal to n times mu x. Any questions so far? Any questions? Okay. So this one, according to the formula here, right? According to the formula here, what is that equal to? N times mu x. So you have 2 times mu x times n times mu x plus n times mu x squared. Okay? Any questions so far? Questions? Which one? This one? This one? Square? Here? Oh, sorry. Thank you. So this is summation xi squared. Okay. Okay, let's move on. So this is 1n times mu x squared, right? This is 2 times mu square, 2 times mu x times n times mu x. So what do you have here? You have 2n mu x squared, right? But here it is minus. Okay, minus, and here it is plus. So what do you have? You have 1 over n summation xi squared minus n times mu x squared. Okay, so this is the result. So the result is that sigma x squared, that's the population variance, it is equal to 1 over n times summation xi minus mu x squared. And it is also equal to 1 over n summation xi squared minus n times mu x squared. Okay? And of course we can simplify it further. Okay, we can simplify it further. What do we have? We have it is equal to n 1 over n summation xi squared minus mu x squared. So of course a lot of times you can apply this formula, right? But remember, suppose you have a lot of numbers, then you have to be very careful here because it is more complicated here. But suppose you know this formula, right? It is much easier. Okay, this one is much easier. Okay, any questions to this point? So for population variance, we have two formulas. The first formula is here. Okay, 1 over n summation xi minus mu x squared. The second formula, 1 over n times summation xi squared minus mu x squared. Okay, the same thing here. Let us try once more. Okay, any questions? Any questions? Then we're going to do here. Okay, we're going to work on here. The same thing, what can you expect? So this one can be simplified as 1 over n minus 1, okay, summation xi squared minus n times x bar squared. Okay, exactly the same as what's going on here. But here it is 1 over n minus 1, and here it is minus n. Okay, so basically this is the formula above. And here, okay, if you look at the screen here, this is a different kind of formula. It's for group data. Okay, so this is for ungrouped data. Okay, and this is for the group data. So what's the difference? The difference is here. So because it is a group data, so you have frequency, right? Frequency, Fi. So xi times Fi. And what is xi? Xi is the midpoint, right? I mentioned that. It is the midpoint. And times the frequency, okay? And of course, depending on how many do you have. For the sample, it is 1 over n. For the population, 1 over big N, okay? So this is for the group data. And of course here, you see, here is from 1 to n, right? From 1 to n. And here is from 1 to k, okay? Because you may have k groups, not n groups, okay? So suppose you have 100 persons. Does that mean you have 100 groups? Not necessarily, right? So here you have from 1 to k. So you have k groups. Okay, you have k groups. And here you have n numbers. And basically the same thing for the sample variance. Okay, it is 1 over n minus 1. But because it is a group data, so you have to time that by what? By the frequency. Okay, by the frequency. And the same thing here. So as you can see, what's the difference between group data and ungrouped data? So here, because you are talking about ungrouped data, okay, this is the ungrouped data. So what's the frequency for each number? It is 1 over n, right? It is 1 over n. But this is group data. So what is the relative frequency? It is Fi over n, okay? So Fi is here, right? And the 1 over n is there. So Fi over n. So that's the relative frequency. Fi over n. And what's the relative frequency here? 1 over n. So basically that's the same thing. It is just one is grouped, one is ungrouped. Okay. Any questions so far? Questions? Okay. So we're going to look at the class, okay, the height of the class again. And then we are trying to apply the formula, okay? And the formula is exactly here. And we're going to move on. Questions? Okay. So for the data we have, the first group is from 170 to 175, right? So what's the midpoint? The midpoint is 172.5. How many? What's the frequency? It is 5. Okay, can you see that? And the second one, 167.5. How many do we have? We have 9. So the frequency is 9. And you have to divide it by what? By the total number. The total number is 56. Okay, the total number is 56. So basically, you just apply the formula, okay, plug in the numbers, and you can get the result. Okay, so it should be easy. And it is a little bit more difficult here because you are talking about variance. Okay, it is a little bit more difficult. It is xi minus mu x squared, and you have to time that by frequency. Okay, so 172.5 minus the average. Okay, so because you calculate the average is 160.37, right? And so you have to apply that into this equation there. So 172.5 minus the mean and square that and times that by the frequency. So it's going to be very important here in exam. Okay, when it comes to exam, okay, plug in as many numbers as you can because you calculate it by the calculator, right? You calculate it by a calculator, so that is no cost to you. So basically, you know, here I have some rounded. Okay, I have the number rounded. Supposedly it can be 163.75423. Okay, whatever. But I'll only put down 160.37. So when you calculate that, okay, you have to leave all the number there. Okay, so as you can see, if you rounded some of the number, okay, then there is going to be some discrepancy, some difference in terms of the number. Okay, but don't worry too much about it. When you put down your exam, I will look at your formula. Suppose your formula is correct, but the number you get is wrong, you still get some credit for it. Okay, you still get some score for it. But suppose you get the wrong formula, but you get the right number, you got 0 point. Okay, you have to see the difference here. And now I'm trying to give you some, you know, multiple choice question and fill in blanks. So in this case, there's no way I can see your calculation. Then you will be in trouble. So try to make sure that apply as many number as you can. Okay, so let us say the number you get from the calculator is 160.374321. Suppose it is the case, then you have to plug in the whole thing. Okay, because you are doing that by calculator. Supposedly you don't have to calculate yourself. You just plug in the number. Okay, so make sure that you get this. Any questions? So supposedly we have to we are at chapter 4 or chapter 5. Okay, so when you get a book, try to read as soon as you can and practice some of the problem. Questions? Let us move on. So when you group data, okay, so the example we have is we're talking about the height of a class, okay, the distribution of the height of a class. So of course you don't want to get too many groups. If you have too many groups, you lose your focus. Okay, so you don't get too many groups. So here the first point, you not too many or too few categories. Okay, don't get too many groups or too few groups. If you have too few groups, it doesn't make sense. Okay, if you have too many groups, sometimes you lose your focus. Okay, and then the interval can be different. So for example, in this class, the average is about 165 cm, but somehow we have a person very tall, say 200 cm. So let us say the tallest person is 200, and the next one to the tallest is 175. What happened? if you have 5 centimeter as a class, okay, so 170 to 175, and then you have 175 to 180, 180 to 185, etc., right? But the point is, from 200 to 175, there is only one person. Okay, do you need to put down that many groups? You don't. So sometimes it can be open-ended. What means open-ended? So you have this group to 175, right? So then what's the above? The above is all the persons greater than or higher than, taller than 175, and there is only one person. So the difference or the interval can be different, okay, the interval, and sometimes it can be open-ended, okay. The next one is about inclusive. What means inclusive? Because when you divide a group, okay, divide the data into several groups, you have to have everyone included in your presentation, okay. You have to everyone included. And what means inclusive? Exclusive. Exclusive means that one person can only be in one group, okay? One person cannot be in two groups, okay? So this is very important. And then midpoint to represent the value of the class, okay? We talk about it, okay? In the calculation we just show you, okay? It is the midpoint to represent the whole class. Okay, and then the next one I just mentioned, if there is extreme value, okay, so let us say, you know, some people very tall or some people very short, what happens? You can have open-ended. So you say, for all the people greater than 175 as a group, or all the people, for the people shorter than 160 as a group. So you can do that, open-ended. Okay, any questions? Now we are going to talk about diagrams. A good diagram or chart is much better than a whole bunch of numbers. Okay, later I'm going to show you. So this is the population statistics of Taiwan from 1957 to 2003. So here there are some whole bunch of numbers, right? Can you see anything? Probably not, because just too many numbers. So sometimes if you look at the numbers very carefully, you can see something. But in terms of this number, you know, just too many. You cannot see a focus. So sometimes table is quite enough. Okay, sometimes table is quite enough. For example, the table we just have, the distribution of the height of a class, right? Very simple. You have 6 groups, and then you can see clearly the picture. But what about this one? You just have too many numbers. Okay. Can you see anything? Not quite. But from all this information there, so what's the important information there? You can see one is the birth, okay, and then the death rate, okay, birth rate and death rate. So here we are going to see a trend. Suppose you want to see a trend, the easier thing to see is by drawing a diagram. Okay, so let us move on. So can you see this here? Okay, we have a graph, okay, so a chart. Rate of the population increase in Taiwan. It is from 1957 to 2003. So for all those numbers, can you see anything? Not quite. But here you can see the population increasing at a decreasing rate. Okay, so here you can see in 1957, the increasing rate is about 3.5%, right? What about now? It is close to 0.5%, okay? So you can see the population is going down, okay? The increasing at a decreasing rate. Even though at this point it's still increasing, right? But it is increasing at a decreasing rate. Okay. So here is the birth rate, and here is the red line. Okay, the red line is the death rate. So we know there is a trend. The population is increasing at a decreasing rate, but we want to know what's going on. So here you can see the death rate. Okay, what's the percentage of people dying? The death rate is quite stable, right? The death rate is quite stable. But what about the birth rate? The birth rate continues to go down, okay? So then you see what's the problem, okay? The same thing in Japan. The birth rate is going down dramatically, but what about death rate? Death rate is about the same. Okay, let us move on. Okay, here is another statistics. It's about earthquake. So earthquake casualty statistics in Taiwan. What means casualty? Casualty means people die. Okay, how many people die when there's earthquake? Okay, or how many people die because of earthquake? Okay, casualty means die or wounded. Okay, basically like this. So here you have a statistics. Okay, the first one is casualty. Okay, and then you have several groups. The first one is northern Taiwan. Okay, the first one northern Taiwan. The second one is central Taiwan, and then the southern Taiwan. Southern Taiwan including Yunlin, Jiayi, and Tainan, and then Kaohsiung. Okay, and then east part Taidong, and then Hualien and Yilan. Okay, for all these regions. So if you look at these numbers, you can see a clear trend. If you are running an insurance company, okay, let me repeat this again. If you are running an insurance company, okay, suppose people in central Taiwan want to buy insurance from you, okay, and there's people from northern Taiwan. So suppose there are two kinds of people. One people from northern Taiwan, the other one from central Taiwan. They want to buy earthquake insurance from you. Which one you're going to charge more? The person living in northern Taiwan or the person living in central Taiwan? The person living in central Taiwan, because here you can see the death rate is much higher, right? So for this year, 1900 to 1998, for about 100 years, right? For about 100 years, how many died of earthquake? Okay, how many people died because of earthquake in the northern Taiwan? It's only 60 people, right? What happened in central Taiwan? It is 16,166. So suppose these people want to buy insurance. The premium for those people living in central Taiwan should be higher, right? So here, it is a very simple table, but it gives you information about insurance policy, okay, about the premium people are going to pay. And suppose, okay, suppose people living in Kaohsiung want to buy insurance. This should be a good news to you, right? Because no people die in these 100 years, okay? So basically, they pay you premium. Do you have to pay them indemnity? Indemnity means you compensate for their losses. Do you have to do that? No, because 0 people die, okay? So even though this is a simple table, it tells you some very precious information. So here we are talking about casualty, you know, how many people die. We're going to look at the next chart. It is a diagram, right? Shows you clearly for those people living in North Taiwan, Kaohsiung, and what's the other area? Yilan. Okay, for the people living in this area, it is a very good news to you, because if if these people living in this region, they're going to buy insurance from you, basically you're going to make a profit out of it. But what about in central Taiwan? There is a great risk, right? There's a great risk. Okay, we are talking about the housing damage. Okay, the same thing. Housing damage, the most serious part is in central Taiwan and southern Taiwan. Okay, what about Kaohsiung? Very minimal, right? Very minimal. Okay, the same thing. Okay, this is a pie chart. Okay, show you that in terms of diagrams, it's much more powerful. Can tell you exactly what's going on there. The same thing. Okay, earthquake casualty. Okay. So now we are getting to this part. We are going to talk about the cumulative frequency and cumulative relative frequency, the cumulative frequency and the cumulative relative frequency. Probably we're going to stop here and we're going to continue next week. Okay? Thanks.